Hi everybody. So this section is titled 6.4, The Method of Cylindrical Shells. In this section, it's just another method for us to find volume as we rotate a region around an axis. Sometimes you found in the previous sections, such as disk and washer methods, it wasn't always that easy to find that volume because you had to solve the equation as a y equals versus solve the equation as an x equals. And sometimes that's just not possible. So here's another method that you can choose to use, and it might make certain problems easier than others. When I think about this cylindrical shell method, I picture a roll of Scotch tape, for example, right? And if I were to start taking Scotch tape off, it would unravel, correct? And give me a shell, one circumference at a time. And those shells or those circumferences are concentric, right? So each shell of Scotch tape, it has a little bit of depth. And in this case, when we do these integrals, it will be the same scenario. So if we envision each of those shells, the only difference between my Scotch tape visual and the shape that is now wrapping around as a shell is the heights of them will change, right? It's not going to be the same height of tape every single time, but the circumference concept will remain the same. Okay. So formula for this, as I was suggesting, it's going to be our circumference times our height dx, integral from a to b. So the 2 pi radius that you see in here is that circumference portion of it. The height of the shell, which when we integrate in this direction will just be the function, and the limits of integration go from a to b. Those are going to be x values. So let's take a look at our first example here. I put the formula up top again just as reference as we go through the first one. Pictures given, which is always nice, right? The original two-dimensional function versus what it would look like if we use our shell method. And you can see we have in here one shell at that particular height, right? Okay. So find the volume of the solid obtained by rotating the region under the graph of 1 minus 2x plus 3x squared minus 2x cubed over 0 to 1 about the y-axis. So if we had done this the other way, right, if we were just thinking rotation, disk or washer method, we would be spinning horizontally, which means that our radius would be an x equals, which means that we would have had to solve this equation for x equals, and that would not have been possible. So this method is much, much easier. Because in this case, now I like to break this up. I like to think first, what is our circumference? And it's always that, of course, basic formula of 2 pi r. And the radius in this case, if you take a look at our shell, like I was saying, it's x equals, but it's just what is the x value? Right, whatever that x value is within our limits of integration. So 2 pi x will be our circumference every time. And then our surface area, we're really thinking about what's the surface area of that one shell. If we can come up with the surface area of one shell, then we can find all of them through integration. So our surface area would be 2 pi x, right, the area of the circumference around, times the height. And the height in this case is f of x. So this would be the same as having 2 pi x times 1 minus 2x plus 3x squared minus 2x cubed. And if we want to come up with our volume, right, we're going to integrate it. 2 pi x, the 2 pi, of course, you can take and put out in front. That's up to you. 1 minus 2x plus 3x squared minus 2x cubed. The dx, right, of course we need it. It's notation. It's important. It has to go hand in hand with that integral. But it also signifies that depth that I was referring to, right, that depth of this shell. So last step, we take a look, what are our limits of integration? So in this example, they told us 0 to 1. Sometimes we'll have to do a little bit of work in order to find those. Absolutely, Math 9, and your answer will come out to be approximately 1.152 to the nearest thousandth. So before we get into example 2, I wanted to talk a little bit about this paragraph, but of course you can read it on your own time. So conceptual insight here, shells versus discs and washers. So as I was referring, if I talked about this as kind of the carousel method, right? If we're rotating about a vertical axis, that means that we are spinning and we are creating horizontal slices if we're talking disc and washer. And when we have a horizontal slice, our radius is running as an x equals value. So if you have an equation that you could easily write or solve for x equals, then you're fine with that method, right? There's no issue there. But if you have an equation like that last example that you can't, you would be choosing your shell method. The opposite would be true, right? If I'm doing something that's rotating about a horizontal axis and I'm rotating vertically, I want to use the method that allows me to use the y equals equation that's given. That would be most commonly the easiest method. So in that case, you might be better set up to use your disc and washer method. So it is up to you. With the 6.4 quiz, I'm going to ask that you set up your shell. But once we come to the test, and down the road for the AP, of course, it's a matter of what does the problem lend itself to? What method will be the best for me to solve with? All right, so this formula here also, right, that second box, number 3 there, what if there's more than one function, right? So if there's 2 functions that we are now looking to find the shell of, same idea, right? Top minus bottom, right minus left, etc. So in this case, we're still finding our circumference, the 2 pi x, and then the height of the shell will be the difference between f and g. So example 2 is the region between 2 curves. Find the volume V obtained by rotating the region enclosed by the graphs f of x equals x times quantity 5 minus x, and g of x equals 8 minus x times quantity 5 minus x. All right, so in this example, I'm not given what my limits of integration are. So in order to figure those out, I do have to set these equal to each other and find my points of intersection. So I'm going to do that first. Before I go there, I noticed that it almost appears to be factored form on both equations, but g is not. So I'm going to put everything in standard form. So g of x is equal to 8 minus 5x plus x squared, and then f of x is equal to 5x minus x squared. So if I set those two equal to each other to find my points of intersection and my limits of integration, I'm going to move everything to the right-hand side, set it equal to 0. I'm able to divide by 2. And factoring, I would get minus 4 and a minus 1. So my zeros are 4 and 1. Okay. Without going to my graphing calculator, right, I just want to get a quick visual of what this is going to be. And most importantly, I need to acknowledge what's above and what's below. So if I have points of intersection at 1 and 4, the first function, f of x, is in intercept form. So I know that I'm here and here, respectively, 0 and 5. I know that I'm opening downward. Okay, so it's got to be something along those lines. I know that I intersect at 1 and at 4. Okay, so then my other function, my g, it does open upwards. I don't really care where the vertex ends up being, but I do know that it's going to be, below of some kind. I'm not sure exactly, like I said, where the vertex is, but it really doesn't matter. I needed to confirm that f is above g in this interval. Okay, and so now let's keep going. First job, figure out your circumference, right? And because we are going about the y-axis, right, we're right here still, so that region is roughly the same thing on the other side. Still reflects in the same way. And now we're trying to think about what that... Not as good at drawing these, but basically what that would look like. Okay. So, right, the radius is still that x value. It hasn't shifted in any way. And I didn't draw this touching, I should have. And the height is still going to be the function value. So we're still going to set up the integral of 2 pi x times the difference between red and blue, or g, f minus g. So here's our height, here's our circumference, dx is the depth of that. Our limits of integration go from 1 to 4. Okay? And again, like I said, for the AP, you wouldn't have to rewrite this with the functions written out. You obviously have to put this in the calculator correctly, watch out for your parentheses, etc. But if you wrote down your integral for your work like this, you're fine. F and G are already properly labeled in the problem, so we are fully defined for this integral. So this is approximately equal to 141.372. We have 2 more examples for this video. So here we have rotating at about a vertical axis, a different vertical axis. Use the shell method to calculate the volume V obtained by rotating the region under the graph of f of x equals x to the negative 1/2 from 1 to 4, about the x-axis of negative 3. So here's negative 3 over here. F of x, f of x, which equals x to the negative 1/2. Something like this. Okay. Calculator active, so it's totally fine to go and check it on your calculator. We have limits of integration from 1 until 4, so it's this space right here. And we are going to be finding the shell as this is reflected roughly over to here. So now the big difference here, since we shifted our axis of, I don't want to say rotation so much, but the axis that we are reflecting across, at least, it still is a rotation, just a different type. Now that made our radius change, right? So now our radius goes from here until wherever we are hitting, right, on our graph. So if this is the shell that we're looking at, our radius has now grown by 3 units. So we have the integral of 2 pi. You can still think of it as right minus left, so x minus negative 3, or visually it increased by 3. And then our height is the function, x to the negative 1/2. We need our dx. Our limits of integration as given are 1 until 4. So math 9 becomes 67.821. All right, one more example, and this one we are going to go about the x-axis. This is different. But in order to do that, of course, we must be given an equation that I can rewrite. So use the shell method to compute the volume V obtained by rotating the region under y equals 9 minus x squared from 0 to 3 about the x-axis. So I'm going to sketch it as it's given. So it's a parabola that opens downward. We're up here at 9. We cross over at 3. And we have that region right here. Okay. And if we are just simply reflecting it, we look like this. So now, if we want to go that way, see if I can sketch this properly. so now our height runs here. Right, and our radius runs there. So our radius is now the y. And our height is the equation, is the function. Except we can't write it the way it is because you can see that the function is running, the height is running right to left. So that's an x value. So we have to take y equals 9 minus x squared, and we have to solve it for x. So square root of 9 minus y. Okay. So now we can go to our integral. We have 2 pi r, or y in this case, times the height, root 9 minus y, dy. We have y coordinates, so we need to go to our y-axis to take 0 to 9. So the values that were given in the beginning were x values. We need to acknowledge that, and then we need to take the y values for this problem. Okay, so putting this in your calculator, Math 9, and you will get the answer of, just give me a second, I'm seeing 407.150. Remember, you don't actually have to type in y's, you can just type in x's if you choose. Awesome.